Thank you, Chairman. Good morning. It's a real pleasure to have the opportunity to speak second. I thought I was speaking first, but António stole that. No, it's just it is indeed really good to speak on this topic on offshore renewable energies. But as usual, when somebody asks you a question and you don't know the full answer, you turn the question to fit the answer that you know how to answer. So despite the fact that it's offshore renewable energies, I'm going to concentrate a lot more on wind, offshore wind. And I think Professor Falcão is going to speak on waves anyway, so maybe we might miss on the title, but hopefully it'll still give you plenty of food for thought. I don't know how many of you know anything about LOC. No hands up, so that, 3 or 4, excellent. Just to briefly, we work in three sectors, oil and gas, renewables, and shipping. And of course, the biggest single point for which we are well known is in marine warranty, and particularly in offshore wind. So we're probably number one marine warranty surveying company in offshore wind. So we are essentially technical people of different skill sets. So having quickly done that particular advertising, I'll move on to the technical topic. So offshore renewable energies. When you talk about offshore renewable energies, there are three main aspects that we tend to think about. Not quite offshore, but now we have some floating solar farms in the UK. Probably the largest floating solar farm, but that's not quite offshore, but it's important. Leaving those extreme special topics, primarily we are talking about wind, tidal, and waves. And I just wanted to kind of highlight the magnitude differences in terms of current installations between the three sectors and the forecast installations to 2020. So we think that we are likely to have around 40 gigawatts, maybe a little bit less. And so far we are about 15 gigawatts of capacity that's installed. But in tidal and wave, it's actually quite small. And I did do some research into looking at what was the energy transition outlook that the industry has today with regard to looking at 2050. And lots of people do this. There are about 6 or 7 oil companies do it. It's quite an interesting read because they all follow in one form or the other a kind of scenario planning concept that Shell got famous for. And in none of those do you ever find that in the 2050 there is a significant contribution from wave and tidal. I'm particularly provocative this morning, so just shoot me down later. But I think the key point here is that it is a technology that is still struggling to find its unique way forward. I then identified Shell actually did this 2 different scenarios. So they have scenarios which talk about shale oil becoming pretty big, and the other one is renewables. And in neither case do you see wave. They do actually call out wind very heavily. All of these projects, all of these scenarios look at wind as a major renewable energy source for time to come. And of course, photovoltaics is going to be even bigger. IEA, BP, Exxon, all these people, it's very easy. As I learnt early on that I think Picasso was the one who said that good artists copy, great artists steal, so I stole a lot. And I've referenced to you at the back all the places where I've taken information from that has helped me to produce this document. But none of these really dissent in terms of the contribution of wind. Offshore wind is going to be quite big. So what are the market trends? There was a study that was done towards the second half of this year by a group called Douglas Westwood, and that looked at the investment levels that are going to be taking place in offshore wind. And what is clear is that we are heading towards a $50 billion industry. That is capital expenditure of that sort of magnitude. Now, if you want to put that in context against the kind of the big bad oil situation, we are talking about 1/5, something of that order. And of course, oil E&P is also going down now. So this is a growing industry, and even though you see some tail off at the end in the longer plan, you could quite well say that that's only because we don't really know all the projects as we go that far forward. It's the trend is probably still upward. I don't know how many of you read this magazine that's produced by Ernst & Young called Renewable Energy Country Attractiveness Index, which is a very nice summary, and that looks at every renewable energy source that goes into the energy mix. And I just focus myself very much on the offshore wind question, and I think the forecast is that by 2024, UK will be eclipsed to #1 place by China. And you can already see the major moves that are going on in China with regard to offshore wind. And the key part of that is because they are not interested in hypothetical or discussions and hoaxes and all this kind of stuff about climate change. They are very much interested in the now and today, which is the pollution topic. And therefore there is a move that's going on that's far more aggressive, consistent, and quickly realized because of the political system that's there. So I think China is likely to lead on. The other stars that I put up there, I'll just talk on the green stars, is France, US, and Taiwan are likely to come into the top 10 in the world. And I can certainly say from our own company's experience, certainly on France and Taiwan, we are seeing a very big push for developments, even though we have some kind of environmental impact issues that are holding things up in France. But I think it'll break through at some point. And in the US, the first demo has happened, but I'm not, unlike a lot of people, I'm not so confident that it is going to happen before this side of the 2020s. I think it's probably 2021, 2022 that we will have the first seriously commercial offshore wind farms in production in the US, but maybe I'll be proven wrong. The other interesting forecaster is worth looking at, and they do a lot of very regular updates, and in particular they also update some of the pricing for offshore wind, and that's Bloomberg New Energy Finance. We have in our conversation, you don't have to even about guessing whether these are going to happen, because a number of about 28 gigawatts in place. So there is the numbers that I was talking to you about, 40 gigawatts. These are not pie in the sky. They're actually damn close to things that are already signed up. So that is just a quick summary, which is there for you to read. I don't think I've got, which is pulling together all the data that one can gather in evaluation in terms of trends that will be happening in the next 10 years. So I want to leave with kind of three key messages in terms of the the market trend. I want to get to the technology trend in a minute. Market trend, in a current economic situation that we all face, offshore wind is a really sexy growing business. It's a 20% per annum compound annual growth. Although, to temper that excitement a little bit, because the prices are coming down. So that means the money that is being made out of it is going to not grow at that 20% rate. Again, I'm making all these statements which are entirely my prejudiced positions, so please feel free to argue about it, and I'm sure we'll have the debate in the various sessions later on. And a total of around $500 billion will be spent. So those are the kind of three guys. The technology trends, I will try to quickly, I mean, I was given 15 minutes and I don't know how far I am. I probably should be fast. So next, 5 minutes? Sorry. 5 minutes, right. 5 minutes, and it's the bit that I really get excited about. But anyway, the technology is very much, I think it's pretty difficult to explain everything within that time. But so I'm going to quickly touch on the points that I think are interesting for me. And my background very much has been in 3 decades in oil and gas, primarily focused on hydrodynamics of offshore structures. So I still hark back to figuring out why is this new industry refusing to learn, and why is the oil and gas industry think that they're all getting it wrong. I mean, so I'm always interested in that topic. So I think the research topics that we have, the technology trends and innovations that we need to make on wind resource, in modeling, atmospheric modeling, and I think it's already pretty sophisticated, but I don't see much cross-fertilization between oil and gas hindcasts that have been going on for the last quarter of a century at least in the oil and gas business. And that cross-fertilization might speed up and give us a faster way of getting knowledge that will produce bankable annual energy production information. The second is in measurements. Of course, I think all of you are probably well versed in the topic that we are now going to move further and further away from potentially anemometer measurements to LiDAR measurements, provided all the contractual arrangements can be made to work in terms of turbine specifications. In terms of turbine technology trends, there are possibly 2 angles, although I come across people who are religiously one or the other and will never countenance the alternate technology. But fundamentally, I think that the innovation questions deal with drivetrains. I mean, what sort of, are we going to go further and further towards direct drive, as Siemens is doing, or are we going to do gearboxes as we grow bigger, even as MHI Vestas is doing? So drivetrains would be an innovation topic that will keep the technology on its toes. The second is scale. I saw that we are now very close to 10 megawatts. And if you then think about, as a hydrodynamicist, I get excited about floating structures. So I think if you go to floating structures, you need to then get some pretty large scale turbines in order to make that commercial. And the third is downwind. As you go into heavier and typhoon areas and you want to make production, and you have material flexibilities to consider, is there a question that we should have look at downwind turbines rather than the conventional upwind turbines? And on vertical axis wind turbines, it's an arguable point. I think the fundamental point of part of the blade going against the wind during the rotation is always going to impact on the efficiency. However, there are some pretty positive things that would come out as a result if you were to put it on the fact that you don't need yaw bearings, and you probably don't need to have working at height, which is an O&M issue, which is probably about 40% of an LCOE calculation, to to help you to maybe make sense of vertical axis wind turbines. Foundation technology trends, I'll broadly say I think the fixed part of it, I guess, is pretty much resolved. And I think the challenges that we see relate very much to the floating structures. And in floating structures, the prize is still exciting because speed is high, turbulence is much less as you go further out. And of course, now that we can marry the scale from the turbines, that we might actually see commercial production of commercial projects on floating offshore wind, certainly by 2025. I think I've gone too far already, but very quickly, I just wanted to highlight the electricity transmission. I think it's going to go further and further towards higher voltages. And that means then dynamic design. Along with floating structures and higher voltages, you need to have the ability to design dynamically. And then the next question is on distributed substations. I'm nearly there. And then on installation, the big move is going to be from jackups to DP. I remember even about a year and a half ago talking about it in my office about doing high and tall lifts with dynamic position vessels, and everybody poo-pooed it. Now we have the situation that at least two manufacturers are involved in building dynamically positioned vessels that are capable of lifting 3,000 tons, maybe even 1,500 tons at 150 meters high. So I think we are going to move further and further towards floating access for wind farms. And O&M, I think O&M is going to be very much access, instead of access there, the remote management of offshore wind farms is going to be very big. And we already see this in really complicated situations in offshore oil and gas, where there are people are stimulating wells by simply sitting in an office. Because you can actually get horizontal drill through to the well site to get all the information. So this is going to be my belief is that the less people you can put offshore, the safer the whole project goes along. And of course, safety is also then cheaper for us to do. I quickly show you IRENA one, and I will jump through that, but I thought I'll just finish with my crystal ball, which is, I think we started in individual turbines, people really fine-tuning them, small. Everybody had their specialist little areas, and it was fixed, and it was the trend would be farm level integration, greater than 10 megawatts, control that is integrated, that is to say the structure, the turbine and the foundations would be integrated in the control systems, floating structures, very remote access, as I've said to you in the O&M piece, and eventually dispatchable. As you know that Batwind, Statoil has put in this Batwind project, which is to also try to smooth out the variability. But I think it still has quite a big jump to go to. Thank you very much, and I'm sorry I've overrun.
The oscillating water column, you can see a few pictures here, is possibly simplest and most reliable type of wave energy converter. Not everybody will agree with that. And is the most extensively studied and tested, including especially prototypes. And you can see here a lot of prototypes in Portugal, Australia, Spain, South Korea, Japan, and Ireland. So we can see that there have been quite a number of prototypes deployed into the sea and tested. Now I would like to mention the Portuguese OWC pilot plants. of Pico, the island of Pico in the Azores, because it's quite a special effort done in Portugal. So this was mostly developed in Portugal with funding from the European Commission, and it operated between 1999, when it produced energy for the first time, and present time. It's still operating, which is quite remarkable. That is 18 years. Not continuously, but it's still operating. And this is longer, I think, than any other energy converter worldwide. The plants will be discontinued in 2018, next year. Now, in the last few years, the technology development effort in Portugal, mostly at Instituto Superior Técnico, focus on the following points: floating, oscillating water column converters for offshore deployment and large-scale energy production, new types of air turbines for this kind of plants, and this is being done with Portuguese company Timaner, and there will be a short presentation by Timaner later in the morning here. And some niche market applications of wave energy converters, and I will name wave-powered oceanographic buoy. This is being developed in conjunction with the University of the Azores. Wave-powered docking station for autonomous underwater vehicles, that is AUVs. This is a recent topic of research at IST. And wave-powered platform for aquaculture support with WavEC, and there will be more presentations later in the morning about aquaculture. Now, floating OWC converters for offshore deployment. I mentioned here the so-called OWC spar buoy, which is a type of oscillating water column. And you can see several pictures. On the left-hand side, you can see a prototype. The picture was taken in Nazaré, and models were tested in UK, in Narek, and in Plymouth. And you can see on the right-hand side a larger model. I would say this is a small prototype that was built in Spain. It's being tested in the Bay of Biscay, not far away from yes, Bilbao, far away from Bilbao. You can see here that these models are being tested, the other ones, in UK. This means that it's not possible to test wave energy converters except very small models here. So we have to go abroad, either to Spain or UK or France or elsewhere. Now this is another completely different concept for oscillating water column that is being developed for some years at IST. It's so-called Eugen, and it's a rocking floater with oscillating water column is inside. So the airflow is in short circuits. It's not within a chamber as atmosphere. It's an interesting conception. And you can see a model being tested in Brest, in France, again abroad. Now, floating OWCs for low power applications. This is a different scale. That is for power levels about 1 kilowatts or so, or a few kilowatts. And wave-powered oceanographic buoy and wave-powered docking station for autonomous underwater vehicles. And you can see the power module. That is the drawing that is being developed at IST. Development of special air turbines for OWC applications. This is an important topic because there is a wide market for that. Portugal, and especially Timaner, is almost only supplier of special air turbines for this kind of application. And you can see here a turbine that was developed from the aerodynamic point of view at IST, as mechanical design and supply was from Timaner, and it's being tested in a floating platform in Galway Bay in Ireland. And this is a European project, Cordes. You can see the name of Kimaner on the right-hand side. Now, a very different type of air turbine was developed and patented in IST. You can see here tests being done. This picture was taken a few months ago, 2017. This is called the twin rotor self-rectifying air turbine. It's again a European project, wet fit. And this is quite interesting. This is, again, a different type of self-rectifying air turbine for OWC applications. It was, again, patented in Portugal by IST. And you can see here a prototype that was mechanically designed and supplied by Kimaner. And you can see being tested at IST in a large rig. This picture was taken about June, I think June this year, a European project, Opera. And this prototype was taken to Spain. It's being tested presently at one of the OWC plants in Breakwater. You can see pictures here in the port of Mutrico in Basque Country. And you can see pictures of the turbine being installed in Mutrico. It's now producing energy. Later, it will be removed and installed in the buoy OWC floating device off of the Basque Country coast. Now, in Portugal, research and development in wave energy and in marine renewables in general is almost totally funded by European projects, although there is some funding from Portuguese government. There is not much coordination between the research institutions and groups in Portugal, and I think this should be changed. And in the case of wave energy, the interest in exploiting the results from Portuguese research and development is mostly from foreign companies. And I will mention Spain, Ireland, Denmark, and UK, not by Portuguese companies. And it is possibly as a result of some unsuccessful demonstration project, namely case of Elamis in 2008. Now, needs in research and development, more involvement of Portuguese companies in research and development, and especially demonstration projects, better coordination between research institutions and groups. Sometimes for us to know what other people are doing, we have to attend an international conference. Exploitation of niche markets, multi-use platforms, integration into coastal and other protection structure, and specific equipment. And there is interest in oscillating water columns integrated in breakwaters, and you have collaboration with Italy. Reinforcement of testing infrastructure. I'm going to finish in 10 seconds. Reinforcement of testing infrastructures with international utilization. This is pilot zone. It's oceanic tank, which does not exist in Portugal, and test rigs for specific equipment, and there are some in IST for special air turbines. And thank you very much.
Good morning to all. It's been a while since I've been in these forums, and it's nice to see some familiar faces. Thanks a lot for the invitation to be here. Well, I come from EDP, from the R&D area, and what I plan to briefly address here is just some words about the potential we see in offshore wind, differentiating a little bit between offshore wind and differentiating a little bit between offshore wind and other forms of ocean energy, a bit the challenges, and then also what EDP is doing in the method, the steps we've taken. So, first point, we do see a lot of potential. I mean, there are lots of scenarios, as Ahilan well presented. let me select one. For example, we see one from the NVGL that says that in 2050, offshore wind will be bigger than nuclear or hydro or coal. And we see this as a concrete possibility, and we are taking concrete steps towards that. But of course, we need to differentiate between what is offshore wind, what is other forms of ocean energy. In offshore wind, I would say it's already a gigawatt market. It's already becoming mature. We see lots of projects. I have different figures from the one Ahilan presented, so I will not tell them. But it's already a gigawatt market. Europe is, of course, a very big player still. It's a pioneer. But I guess eventually they will be diluted in some sense with China and US. But still they are still champions in the sector. And this is about, well, basically bottom fixed foundations, more mature technology. When we talk about deeper waters, floating foundations, there we see a different status, a different maturity. We see pre-commercial stage. Some pioneers like the wind float or high wind are doing their first pre-commercial projects. They have done successful demonstration projects, but it's still a little bit maturing. On ocean energy, perhaps then we can differentiate again into different slots. Tidal. For tidal, I would say this is a megawatt market. We already see some hundreds of megawatts coming. Technology is more mature. There was more technology convergence towards these horizontal axis turbines, and so perhaps this has accelerated the development. So in ocean energy, I guess around more than 90% of the installed capacity is from tidal, and so this is an important, I guess, remark. On the other forms of energy, namely wave energy, as was well presented by Professor Falcão, we see lots of different concepts still. There hasn't been that much convergence still on the technology side. And also what I can see is that Portugal has been very, very active in the sector, namely in the area of research and development and developing new projects. About challenges. For offshore wind, I guess the biggest challenge is cost reduction. Is having the right levelized cost of energy that is able for the sector to scale to a large scale. Some figures. For 2018, levelized cost of energy is around 150 euros per megawatt hour. And there are some scenarios, but some scenarios that we could highlight here. We do see around additional 50% reduction until 2021, up to the level of 70 euros per megawatt hour in 2020-21, or even more if we go 2030, but this is too far along. On the key drivers for this cost reduction, we do see, as was well presented, turbines, foundations, improved in operation and maintenance, interconnection, but perhaps also one thing which was not presented here is the reduction in levelized cost of energy, so the reduction in cost of capital driven by the reduction of risk. As the value chain matures, cost of capital will decrease, and this will facilitate, of course, bigger investment. In ocean energy, the challenges, of course, of a different kind. We need to produce electricity, do it in a reliable way. Systems must survive, and only then this matter of costs will, I guess, be more important. Because I guess first we still need to have significant production, and systems must survive, etc. On EDP side, I guess the rationale here is that for different kinds of animals, different strategies. For offshore wind, EDP has taken several steps. We've been working on the matter. I will conclude in 1 minute more. For offshore wind, we started around 10 years ago. We basically have two large projects being developed. One in UK, in Scotland, Moray first, the east part. It's around 1 gigawatt of installed capacity, and it was awarded a contract for differences in 2017. Well, this will be implemented shortly. And also in France, we have some additional 900 megawatts of installed capacity, which is also being developed, and we has a later COD around 2023, 2024. In floating offshore wind, we have basically two pre-commercial projects following the success of the demonstration of the wind float. One in Portugal, wind float Atlantic, and one in France, wind float Mediterranean, in the 25 megawatt scale for each of them. On ocean energy, it's different. Basically, we have a more on an observatory role. We have been perhaps more active sometime in the past. Perhaps now we are in a more observatory role. We are participating in Horizon 2020 funded R&D projects. We need to understand the state of the art, and we want to contribute to it, but not as actively as I would say as in more commercial, mature technologies that drive our business.
Thank you very much. Patrik Möller from Corpower Ocean. I guess I'll bring a view on wave energy technology. So far, wave energy devices have either broken in storms, they just haven't been survivable, or the amount of energy that they've been able to produce compared to their size, their weight, and their cost has just not been enough. And then you can't make the commercial equation work. And it's not harder than that. And so far, the technical challenge behind that, really, I think, is that if you have too high difference between your peak loading that your device sees in the toughest storm that the device sees through its life versus the average loading that the device sees that generates the revenues, if the difference between those two is too high, then you have a commercial problem, because usually the cost is driven by the highest loads, the dimensions, the technology that drives the cost, whereas the revenues is driven by the average loading that you have. So the whole challenge in Wave is to reduce the peak loading while increasing the average loading to make the commercial equation work. Corpower has taken an approach to doing that, which is very unique. So we're bringing a point absorber to the market, so it's a buoy oscillating up and down in the water. And the first unique feature is that it's transparent to incoming waves in its natural state, meaning it's a very poor absorber of wave energy. It's also, that's why it's not absorbing forces and gives very good survivability in its natural state. Then on top of that, we have another invention that is phase control that makes the buoys resonant when we turn it on. That increases the absorption of energy, and it amplifies the motion with about 3 times when you turn on the phase control. And by that, we're able to get 3 times as much energy out from the same buoy, and it makes a remarkable difference. So by that, by being transparent in the natural state in storms, you can compare that to pitching down the blades in the wind turbine. Every commercial wind turbine on the market has the capacity to pitch the blades. We have now wave technology that brings the same to the wave sector. And then we have a way to strongly amplify the absorption when you want to optimize in normal waves throughout the year. And the net result is that so far we've proven about 3 times as much energy per force, which is a measure of how much revenue you get compared to the cost of the drivetrain, and more than 5 times as much energy per ton of device, which is a measure of how much revenue you can generate compared to both the capex of the device, the amount of steel and concrete and materials you need to invest in to actually build a device, but also the O&M cost, because as you have large heavy structures, it very much drives the transportation, the handling, the installation and retrieval costs of devices. So getting more energy out with less equipment really is the way to drive down the O&M. And we're getting 5 times as much energy now per ton compared to anything else published in Wave so far. So when people say that wave energy has been not so efficient, it might not be what we will be saying in a few years if we continue to hit on the targets that we've been doing. And we've taken a very careful approach. We started small scale. We started and we're doing stepwise verification of this technology. Did the first tank testing in Portugal in 2013 in a small scale 1 to 30 buoys. Then went to 116 in France in the stage 2 test in 14 to 16. And we also did a lot of dry testing of the drivetrain components in the meanwhile. And currently we're testing a large scale device. It's a 4-meter buoy in Orkney in Scotland. And this has been dry tested over the last year in Sweden. We're currently working with multiple partners here in Portugal to see if we can do full-scale demonstration, followed by a small demonstration array in Portugal in the next 5 years. So from this point on, I would consider if we continue to hit on the results that we've shown so far, wave energy will be something very different. We have already shown the same amount of energy per ton. So if you talk about structural efficiency, we are matching already the best of next year's. It can be easily beaten because you get more than 5 times as much energy per square meter. I mean, the energy density in wave is just superior. So I think that is speaking for wave energy, and also the fact that the electricity is produced with a natural time shift to wind. And going forward, cost is all about when you produce the energy. It's not just the cost per kilowatt hour, it's when you deliver it. When it's a very windy day today, you don't want to sell wind electricity. And wave energy has a natural time shift to wind, which I think is a very important aspect in balancing the grids going forward with a high penetration of renewables. Thanks.
Good morning to everyone, and thank you to the Wave Energy Center for inviting me to speak at the seminar. The topic that I propose to bring you is to speak about the measures that were proposed by the government in the recent Industrial Strategy and Action Plan for Ocean Renewable Energy, which was approved very recently, last 24 November this year. And the purpose is to improve and simplify the licensing of offshore renewable power generation facilities in order to improve or to promote the investment in this technology in Portugal. So the Industrial Strategy and Action Plan for Ocean Renewable Energy identifies 3 main areas of risk, of regulatory risk, which difficult the investment in this type of projects. Firstly, we have the need to carry out lengthy and very frequently, at least, time-consuming environmental assessments as part of the licensing process, and the outcome of these environmental assessments is not always easy to. It is uncertain in many situations. Then the second area of regulatory risk or difficulties that were identified in the Industrial Strategy and Action Plan has to do with the fact that investors frequently need to liaise with separate authorities in different time frames in order to obtain the several permits that are required within this licensing process, such as the energy licenses, the title for the private use of marine spaces, sometimes the title for the use of water resources, the environmental assessments, etc. And then finally, we have the risk that after investors carry out typically expensive and time-consuming environmental assessments and liaise with the different entities to obtain certain permits, there is a risk that there may not be enough capacity to connect the project to the grid. So in order to mitigate these risks, the Industrial Strategy and Action Plan approved by the Council of Ministers proposes or contemplates the adoption of a series of measures. First, creating planning instruments or situation plans at the level of the planning and management of the national marine space, which would allow, on the one side, the identification of specific areas in the sea, in the ocean, which could be used for the development of offshore renewable power projects, and secondly, that a prior environmental assessment is made with respect to these specific areas. And the purpose of this would be to improve the legal safety around the feasibility of these type of projects by reducing the or mitigating the constraints that may arise from environmental issues, and this way to reduce the time required to complete the licensing process. Actually, a new situation plan is currently being developed in light of the new regime for the planning and management of the national marine space, which was enacted in 2015. This new situation plan will allow the definition of guidelines for the development of offshore renewable projects in specific areas of the ocean. And we will need to see how the measures that are proposed in the Industrial Strategy and Action Plan will be addressed in this situation plan. Then secondly, I'll try to finish quickly. A second set of measures that is contemplated in the Industrial Strategy and Action Plan is to improve the simultaneity between all the licensing processes and promote interoperability between the different entities involved and the different electronic licensing platforms, so as to reduce the interactions that the investors need to make with the public administration. Once again, the purpose of this would be to increase differently, to decrease the time needed to have a fully licensed project in this field. And then finally, to end, in order to mitigate the risk that after carrying out environmental assessments and obtaining different permits, there may not be conditions to connect a project to the grid, what is being proposed is to create a system that would allow investors to secure ahead the capacity to inject power to the grid by delivering a bond to the grid operator. And this is a system that already exists in the law for renewable power projects in general, which operate with a guaranteed remuneration or a feed-in tariff, but does not exist for market projects or projects that are meant to operate in the market, plants that sell their output in organized markets to specific clients and electricity suppliers and at market prices, which is something that we do not yet see for these type of projects, offshore renewable projects, but hopefully we will see in the future. And that's it from us.
Thank you.